If we know how to figure tax, tip, and discount, can we also work backwards from the final cost to find the original price? Well, let's give it a shot. We know the cost of our new video game with tax is $74.90. We know that sales tax is 7%. So what was the price of our game before tax? Well, let's start with percents and think about what we actually pay. We have to pay for the entire price of the game. There's no discounts here. So that means the price of the game represents 100% of all of it. To that 100%, we're going to add sales tax. So that means we're going to have to pay another 7% in order to have sales tax. So that means when we came up with that $74.90, we paid for 107% of the price in order to get our total. Well, how are we going to use that in order to find the original price? Well, that means somewhere along the way, we found 107% of whatever the original price is to give us $74.90. So now we can take that to an equation. 1.07 is our decimal, times x gave us $74.90. So to find out what x is worth, we can undo our multiplication with division, divide both sides by 1.07. When I do, x comes out to be a nice, neat 70. So that means our original price was actually $70. We can use that same strategy to work backwards on a discount. We know we paid $35 for jeans and they were on sale for 25% off. So what was the original price of the jeans before the discount? Well, let's think about what we would pay. If we were going to pay full price, we would have to pay for all of the jeans. We would have to pay 100% of their cost. But we didn't. We got them on sale. So that means we took 25% of their total cost off for what we actually paid. So that means, in terms of percents, we got them on sale for 75% of the original price. So somewhere along the way, somebody figured 75% of whatever the original cost was gave us $35. Well, we can now make that into an equation and solve it. Change 75% to a decimal. Of is our keyword for multiplication. So 75/100 x gave us $35. To undo that, we're going to divide both sides by 75/100. When we divide 35 by 75/100, that comes out to give us 46.6 repeating. Now this is money, so we're going to have to do some rounding. We're going to round to the nearest penny. That 6 is going to bump, that's up to a 7. So $46.67 when we round that up is what we would have paid if we'd had to pay 100% of the original price. We can also use those same strategies to work backwards to find a percent. If our slippers were originally priced at $15, but we got them on sale for $12, what percent did we save? Well, again, let's start by thinking in terms of what percent did we pay. We know that somewhere along the way, some percent of our original price of $15 came out to give us our sale price of $12. So that means the equation $15 times some percent gives us $12 is what somebody solved. So we're going to work backwards and undo that equation. So to do that, we're going to divide both sides by 15. When we divide 12 by 15, we come out with a decimal 8/10. But we're looking for a percent. So first thing we're going to do is change 8/10 to the fraction 8 out of 10, but we want a percent, so we're going to change that to a fraction out of 100. 8 out of 10 is the same as 80 out of 100, so that comes out to be 80%, but that also represents what percent we paid. Our question is, what percent did we save? Well, again, $15 represents the full price. So $15 represents 100% of what we should have paid for it. We know we actually paid for 80% of the original price. So if we want to know what we saved, 100% for the full price minus the 80% that we paid comes out to be 20% that we actually saved off of the original price. Check out the other videos in our playlist and don't forget to click on subscribe. Thanks for watching!